Is 3i.Atlas hiding a massive secret? Is its nucleus really 15 kilometers across? What if one of the most intriguing visitors from interstellar space is much bigger than anyone expected? The latest observations from the Zwicky Transient Facility, ZTF, have sent ripples through the astronomy community. Could the nucleus of 3i.Atlas, the third confirmed interstellar object, be a whopping 15 kilometers in diameter? The answer has huge implications, sparking heated debate and raising new mysteries. But here's where it gets controversial. Some scientists think the evidence is inconclusive, while others see hints of something extraordinary. Let's break it down for everyone, even if you're new to this cosmic detective story. ZTF started monitoring 3i.Atlas in mid-May 2025, when it was more than 6 times farther from the Sun than Earth is. At first, nothing much happened, until early June, when the object began to brighten beyond what would be expected from a plain, unchanging chunk of rock. This glow wasn't normal. Hubble's sharp eye picked up a haze of scattered light, especially stretching 10 times farther toward the Sun than in other directions. And this is the part most people miss. The standard comet tail was nowhere to be seen. Instead, sunlight seemed to be vaporizing ice fragments, creating this mysterious glow. If the object were trailing dust, solar radiation would shove it backward, but that just wasn't observed. This key detail changes how we think about what's happening. But here's a twist. Between mid-May and early June, the ZTF's readings showed no increase in the area that reflects light. Experts call this a plateau, as if the nucleus maintained a steady size for a while. During this early plateau, a model based on Hubble's data estimated the core to be 5.6 kilometers wide. However, ZTF measurements were 5 to 10 times brighter than the model predicted. Could this mean the real diameter of 3i.Atlas is actually much larger? What does this mean? If we use the simplest explanation, that the plateau period shows us the true, undisguised nucleus, then the real size could be about 15 kilometers across. Yes, that's more than 20 times bigger than 2I Borisov's nucleus, the previous interstellar comet, and possibly 8,000 times more massive, assuming both have similar densities. But here's the controversy. Why would we detect a giant like 3i.Atlas before finding thousands of smaller objects? Like Borisov, is the interstellar wilderness really so sparsely populated by massive objects? Some researchers say perhaps giant objects are much rarer, plunging into the solar system only once every several millennia. Others theorize that the path of 3i.Atlas may be so finely tuned that it raises eyebrows. Could it be the result of natural, but unlikely, gravitational interactions? Or even technological engineering? Yes, some have speculated about this scenario, given the object's surprisingly perfect alignment with the solar system's planetary plane. Just imagine, what if its trajectory was designed rather than random? Do you think that's far-fetched? But there's another side. Perhaps the plateau seen in the data is just a mirage, caused by observational errors, and the nucleus is really much smaller. Without firm evidence, the question is still wide open, prompting astronomers to call for patience and more data. Fortunately, the upcoming cosmic close encounter might provide the answers we crave. 3i.Atlas is on track to pass within 29 million kilometers of Mars on October 3, 2025, placing it within the sights of the HiRISE camera aboard NASA's Mars Reconnaissance Orbiter. That camera's exquisite resolution, 30 kilometers per pixel, could finally put strict limits on the brightness and size of 3i.Atlas, 2 orders of magnitude better than Hubble's estimate. Since the hazy cloud around the object is transparent, the central brightness captured by HiRISE will give us the best clue yet about its true bulk. Imagine a detective finally getting a fingerprint match. There's undeniable excitement in unraveling mysteries like these. Arthur Conan Doyle's Sherlock Holmes would surely approve. It is a capital mistake to theorize before you have all the evidence. And as Holmes himself quipped, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. Now, it's your turn. Do you think the evidence will prove 3I Atlas is a colossal wanderer from the stars, or will the mystery shrink under closer scrutiny? Could there really be technological fingerprints behind its curious trajectory, or is that mere speculation? Let the comments reflect your views. Are you convinced, skeptical, or somewhere in between? About the author. Avi Loeb leads the Galileo Project, is the founding director of Harvard's Black Hole Initiative, and heads the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. As the former astronomy department chair at Harvard and a top advisor to the White House and the National Academies, Loeb brings rare authority to the discussion. He's also the best-selling author of Extraterrestrial, the first sign of intelligent life beyond Earth, and co-wrote the textbook Life in the Cosmos. His latest book, Interstellar, arrived in paperback in August 2024.